Okay, good afternoon everyone. So this time we'll talk about the introductory part of the number theory, which is the modular arithmetic. So we have here what is meant by A is congruent to B mod of n. Okay? So what is meant by this given quantities, or A is congruent to B mod of n. So suppose that A minus B divided by n. We of course we could say that A minus B divides n. Okay, if there exists A, wherein this one is actually referring to a whole number. Okay, this one is a whole number. Okay, of course, by simplifying this one, okay, we could say that A minus B is actually K times n. For A now is actually K times n plus B. Okay, K times n plus B. Another one, suppose that n divides A, so we could let as A is equal to Q1, there exists now a quotient multiplied by the divisor n, okay, n sub 1 plus R1. Okay, where R1 is between 0 to n. Okay? Another one, there exists also A such that it is actually equal to Q sub 2 times n plus R2, wherein R2 resides a value from 0 to n. Okay, from 0 to n. So we can now, from that, we can now have a subtraction between this one. Okay, that one. So we could have A minus B is equal to Q1 times n plus R1 minus Q2 or Q sub 2 times n minus R2. Then combining like terms, A minus B times, or that is equivalent to the quantity of Q1 minus Q sub 2 times n, okay, plus the quantity we have in terms of R, or the remainder we have R1 minus R2. We could say that A, or not A, we could say that n divides A minus B, okay, if and only if, R1 minus R2 is equal to 0. Or it means that R1 is equal to R2. Since whenever R1 and R2 are equal, so when we subtract, it doesn't change our answer. So still is given A minus B still divisible by n. Okay? So this is how it works, no? The A congruence to B mod of n. Then let us now proceed to some of the application of this modular arithmetic using the clock. Okay? By using the clock. So let me erase this portion. Okay? Okay, so let us have blow a clock. Para po na itong line. Bigger one. Okay, so we have here 12. And we have here 6, then 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, and 11. Okay? Suppose at this time is exactly, suppose at this time is exactly 6 o'clock. Okay? So what will be the time? Okay? What will be the time 9 hours after 6 o'clock? Or what will be the time? Okay? 9 hours after 6 o'clock. Okay? So how do we use that one using the modular arithmetic? So of course, because we have 6, so that is actually 6 plus the hours that the hours added after this given time is equal to, okay, of course the remainder. Then we have here mode of 12. Okay, why mode of 12? Because the hours is only 12, 1 to 12, or the number in the clock. Okay, so what will be the hour after 9 o'clock? Of course, we have here 6 plus 9, of course 15. Okay, then we have here 15 minus 12 is 3, of course. The answer is 3 o'clock. Okay, 3 o'clock. So, the hour, 9 hours after 6 o'clock is 3. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, we have here 3 o'clock. What about, okay, let me say 12 hours. Okay, what will be the time 12 hours after 6 o'clock? So, we have 6 plus 12 is equal to, we have here mode of 12. Okay, we have here 6 plus 12 is actually 18. Okay, so 18 minus 12 is actually what? Okay, 18 minus 12 is 6. So we have here 6 in here as the remainder. So the answer is 6 o'clock. Why? So we have here 12 man. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer is 6 o'clock. Okay, what about, sir, if the value is lesser than the given quantities in the right hand side? So we have here, if we have here 6 plus another problem, this one is 6 o'clock as our answer. Okay, mode of 12. What about, okay, let me say 4 hours. Okay, 4 hours after, okay, after 6 o'clock. So 6 plus 4, we have directly write that one as 10. Because 10 cannot be divided by 12, so the answer is 10. So it means that 4 hours after 6 o'clock is 10 o'clock. So 1, 2, 3, 4. So the answer is 10 o'clock. Okay? So, and so on and so forth. This one will actually generate, or this modular arithmetic would also generate answers using the clock or using the exact time that you are supposed to identify. Example, 100 hour after 6 o'clock, still you have to use the same concept as this one. Okay? So I hope that this video will help you, okay, studying about modular arithmetic as the introductory part of the number theory.